This is lesson 9 from chapter 15. It's all on regular polyhedrons. All the ones in this lesson you need to know for your next test. So what makes a polyhedron regular? It has to be convex as opposed to concave. Remember, has to be convex. It's a convex solid having faces that are congruent. So all of the faces have to be congruent. It's a solid in that it is three-dimensional, right? And it has an equal number of polygons. An equal number of polygons at every vertex. So several things required in order to make a polyhedron regular. And on page 678, there are 5 polyhedrons. There's a tetrahedron. A tetrahedron has 4 faces. Four faces. And the faces are the sides. 4 faces. It has, well, the faces are actually the shapes of the polygons that make up the polyhedron. All right. So it has 4 faces, and it also has edges. Edges are where 2 of the planes meet, right? So it has 6 edges. That's where the faces meet, or planes, all right? And it also has vertices. And there are 4 vertices. And the vertices are the vertexes of the convex polyhedron, okay? And that's the red one on your page. Now, there's a formula that is not in your book. It's called Euler's, or Euler's, right? Euler's formula. And this formula will always hold true. So if you have 2 out of 3 of these, then you can calculate the other one, okay? So the number of vertices plus the number of faces minus the number of edges will always equal 2. All right, so let's look at the tetrahedron. All right, how many faces? It has 4, how many vertices? It has 4 vertices. Plus 4 faces minus 6 edges. Does that equal 2? 4 plus 4 is 8. 8 minus 6 is, in fact, 2. All right, that's the tetrahedron. The octahedron has 8 faces. Oh, I'm going to leave Euler's formula for a minute. All right, let's look at the icosahedron. The icosahedron, it has 20 faces, and it has 30 edges, and it has 12 vertices. All right, let's see if it works for this one as well. So we have 12 vertices. 12 plus the number of faces, 20, that's 32, right? 32 minus the number of edges, 30, does give us 2. So the icosahedron you absolutely need to know. You need to know it has 30 faces, 20 faces, 30 edges, 12 vertices, all right? And then there's the cube. We know what the cube is, right? How many faces on a cube? 6. Correct, okay? And another one on page 578 is the dodecahedron. A dodecahedron has 12 faces, okay? If you have any questions as you work this one, this lesson, please do email me. I do want to work through numbers 1 through 4, okay? Problems 1 through 4. Number 1 is numbers and names. Polygons are named according to their number of sides. Polyhedra are named according to their faces. Make sense? So what is the number for an octagon or an octahedron? That would be 8, right? An octahedron has 8 faces, all right? An octagon has 8 sides, right? Okay. Now, what would be the number for a dodecagon or a dodecahedron? A dodecagon has 12 sides, and a dodecahedron has 12 faces. All right. Now, number 3 says, what do you think we commonly use for a tetragon? Well, a tetrahedron has how many faces? 4. So a tetragon must then have 4 sides. So it's a quadrilateral. All right. Now, what about a regular hexahedron? Well, how many sides does a hexagon have? 6. It has 6 sides. So if we said hexa meaning 6, a hexahedron must have 6 faces. This is a trick question. But what has 6 faces? A cube. A cube. All right. I will see you in class on Thursday.